Hi, this is the first lecture. Try to get you prepared for the final exam in the lecture class. What I'm going to be doing is working through the problems that are on the handout. So if you look in the Canvas under the module for the class or final exam, there should be a in-class handout that if we'd met in person, we would have gone over as part of reviewing for the final exam. So the first thing on that handout is a question about specific heat. So remember, specific heat is the amount of energy required to change 1 gram of a substance 1 degree Celsius. So the specific heat is specific to a material, and the units are joules per gram degree Celsius. So the amount of energy is in joules, the mass is in grams, and the change in temperature is degrees Celsius. So let's look at this problem. How much energy is required to change 105 grams of aluminum from 22 degrees to 115 degrees. So remember that Q is the heat, so it's the mass times the specific heat times the change in temperature, and that's the final temperature minus the initial temperature. So here we're going from a low temperature to a higher temperature, so our change in temperature is positive. The temperature has increased. So we're going to stick these variables in. Our mass is 105 grams. We've been given a specific heat of 0.903 joules per gram degree Celsius, so our grams are going to cancel. And our temperature change is the change from 115 minus the initial temperature of 22 degrees Celsius. And that comes out to a change of 93 degrees Celsius. So we're just going to multiply 105 times 0.903 times 93, and you should get an answer like 8818 joules. And if we're worried about significant figures, all we have here are two significant figures, so we could rewrite this as 8800 joules. So make sure you can do a specific heat type problem. So remember that the energy can be negative if the change in temperature is negative. So if the temperature is going down, then it's releasing heat. So it's exothermic. And if the temperature is going up, then it's absorbing heat. So it's endothermic.